Good morning, dear student. Myself Sumran Kumar. I am from Patna, Bihar. Currently, I am pursuing BTech in Metallurgical and Materials Engineering at NIT Raipur. Coming to my teaching experience, I have had the privilege of guiding the JEE aspirants like yourself at the institute like ENM Tutorials and 10 Plus Academy in Raipur. And I also, over the past 1.5 years, I have mentored the several students uh, in mathematics, helping them to develop the strong conceptual understanding and problem solving abilities essential for cracking the competitive exam like IIT JEE. So today I am here to deliver a lecture on the topic of sequence and series that plays a pivotal role in cracking the to develop the foundational understanding required for the competitive exam for IIT JEE. And here my aim is to make this session interactive and share the insightful concept which are related to this topic. And if you have any issue regarding this topics, then you can ask whatever the queries do you have. So the topic is sequence and series. So first, the topic is sequence series. The name suggests that, like, first name is the sequence. So first we need to know what is sequence. So sequence is nothing but it is the collection of ordered number, ordered number. Like for example, when we take the example of 1 2, like natural number 1 2 3 4 5 and 6, then we can say that this is the sequence and it follows a specific pattern. And then second term is series. So what is series? So series is nothing but it is the sum of the collection of the ordered number. Like I can write in this way, like series is the sum of 1 plus 2 plus 3 plus 4 plus 5 plus 6, means sum of all the numbers which are present in a sequence, that is called series. So in sequence it is further classified into two parts. First is finite and second one is infinite sequence. So basically what is finite sequence? So finite sequence is nothing but it is the sequence, we can define this finite sequence in such a way that a sequence having the finite number of terms. Like from first example of the sequence, we can easily figure out whether it is finite or infinite. So like you can see 1 2 3 4 5 6. So this is the example of the sequence. And if we count this number like one, we can figure out how many terms in this sequence. If it is countable, then it is called finite. Then second class part of the sequence is infinite sequence. So infinite sequence is nothing but it is a sequence having infinite number of terms, like 1 2 3 4 up to infinite. So in this example, we are not able to find how many number of terms it carries. So if we are not able to finding the number of terms, that sequence comes under the picture of infinite. So here we'll discuss about the sequence, series, classification of the sequence, that is the finite and infinite. Now, in the next, like the concept of sequence and series is clear. Now, moving ahead, like in sequence, we can also define as it is a function. It is a function of the domain of the natural number. Like it is also defined as a function of 1, 2, 3, and k. Now we can understand this sequence with the help of example. Like example 1, we can take the example. So nth term, like in sequence we have n number of terms, like we can denote it as a1, a2, a3, a4, and as an. So if we are able to find a1, a2, a3, a4, and an, then we can easily figure out the required sequence. Like we can take the example an equal to 2n plus 5. If I'll ask the question, uh, can you find the first five terms with the help of this sequence, then yes, we can easily find this value. So like how can we approach it? So we can think with the help of the concept of the sequence. So first five terms means we need to find a1, a2, a3, and a4, a5. So how can we find it? Now by step we are able to solve it. So this is the sequence, it is given in the question, and with the help of this sequence we can find first five terms. So the approach is simple. When we put n equal to 1, we get a1. When we n equal to 1, we get a1. So a1 is equal to 2 into 1 plus 5. So what is the value of a1? 7. Similarly, we can get a2 value. If we substitute the value of n equal to 2, we can easily find the value of a2. Like 2 into 2 plus 5. So 2 2s are 4 plus 5. So 9. So a2 value that we got 9. Similarly, we can find a3 value. Just the simple concept that are delivering here is that just by putting the n value, and we are able to get the a3. So 2 into 3 plus 5, that is equivalent to 2 3 is 6 plus 5 11. And a4 value, just putting the value of n equal to 4, then we get the a4. So 2 4s are 8 plus 5 30. And similarly we can find the fifth term, like 2 into 5 plus 5, that is equivalent to 2 5s are 10 plus 5 15. So by this sequential function we are able to find the required first five terms a1, a2, a3, a4, and a5. Now this is the simple concept that I have delivered till now. In sequence, we can also classify it into three parts that I'll discuss: arithmetic progression, geometric progression, and harmonic progression. So Before elaborating about the AP, like arithmetic progression, first we need to know what is progression. So progression is nothing but it is a sequence having a specific pattern. Like in AP, we have a specific pattern like 2, 4, 6, 8, and 10. This is the example. So the pattern is like that. If we add plus 2 with initial value, we get the successive number. If we add plus 2 with second term, we get the third term. So what we can see here is that by adding plus 2, we are able to get the successive number. So the adding, like the additional number is plus 2 in this AP is called the common difference. So we can say common difference. Common difference is nothing but it is equivalent to the successive numbers minus previous number, like 4 minus 2 is equal to 2. And we can also find the common difference with the help of second and third term. So by difference in difference between third term and second term, we are able to get the common difference. 6 minus 4 equal to 2. Similarly, we can find the common difference with the help of 6 and 8. So 8, when we subtract 8 minus 6, we get 2. So here we getting a pattern, and this specific pattern makes the sequence into arithmetic progression. So, and this is the common difference that I have taught, and now in in arithmetic progression we can uh, represent the sequence into a later form, that is A2, A1, A2, A3, A4, and as does AN. Like A1 is nothing but it is the first term of the arithmetic progression, A2 is nothing but it is second term of arithmetic progression, A3 is the third term, and A4 is the fourth, and so on. AN is the nth term of the arithmetic progression. If we have A1 value and common difference, then we are able to get the A2. How? We know that common difference is nothing but it is equivalent to A2 minus A1, A3 minus A2, A4 minus A3, and as well as AN minus 1. So if we have the value of A2 and A1, then we can easily find their common difference. Now let us take one more example regarding this concept, that is arithmetic progression concept, and we can I can explain it by taking the example of arithmetic progression. So AP is equal to 3, 5, 7, 9, as well as nth term we don't know. So 3 is the first term that I have discussed previously, and 5 is the second term, 7 is the third term, and 9 is the fourth term. So we have the value A1 is equal to 3, A2 is equal to 5, A3 is equal to 7, and A4 is equal to 9. Can we find the value of common difference with these two value A1 and A2? Yes, we can find the value of common difference easily. Like CD equal to common difference is represented by CD. So 5 minus 3 is equal to 2. And we can find the generalized form, that is nth term. Nth term is equal to, in arithmetic progression, the formula of nth term is equivalent to A plus n minus 1 into D. So we have first term, we have the common difference, D is the common difference, but we we can find we are able to find the nth value by putting this A and D. So we can easily find out the nth term. If someone will ask the question, what is the eighth term in this sequence? So for finding the eighth term in this sequence, we just put the value of n equal to 8 in the nth term formula, and we can easily get the eighth term of this arithmetic progression. Like A8 is equal to A plus 8 minus 1 into D. We have the value given over here. A1 is equal to 3 and 8 minus 1 is 7. And common difference we already found out that common difference is equal to A2 minus A1. So this is equivalent to 2. Just putting the value of 2 in place of D, we are easily able to get the eighth term, that is equal to 14 plus 3 is equal to 17. So with the help of this formula, we can find any term of this progression. So in summarized way, in summary, I can sum up this. Like I have discussed about sequence, series, arithmetic progression, finite series, finite sequence, infinite sequence. So this is the concept that I have taught till now, and in the next lecture we will discuss the another concept. Thank you once again for this opportunity.